Hi everyone! In this tutorial we will learn how to use the alignment tools of the Paradox Toolkit add-on to render impossible geometry from different camera angles. You can download the add-on from the link in the video description below, and I also recommend you to watch the Quickstart tutorial. In the first tutorial we learned how to render impossible geometry from an isometric perspective. We just need to delete everything, go to the Paradox tools, create a penrose triangle, create an isometric camera, and that's it. The isometric camera is a camera that has the following camera angles: 64.736 degrees in the X rotation and 45 degrees in the Z rotation. This allows us to see the optical illusion. However, if we change the camera rotation by setting the camera alignment to axonometric and move it a little bit, then the illusion is broken. To create an optical illusion that is aligned to the new camera angle, we have to do the following. I will delete the penrose triangle, I will split my viewport, and I will create a new penrose triangle. Now let's take a look at the illusion alignment options. By default, the illusion is set to be viewed from the isometric perspective. However, we can set the illusion to be viewed from the axonometric perspective, and here put the angle that the camera should be to see the illusion. So if our camera was set to 46 degrees, then we set this to 46 degrees, and we get the optical illusion. Now, it would be rather tedious to remember in which angle is the camera, so you can just set if you don't want to do that, just select camera, and that will copy automatically the camera rotation into the illusion proportions. There is also a way to control the illusion alignment and the camera rotation simultaneously, so that we don't have to guess which illusion alignment do we want. To do so, I'll delete the penrose triangle, I will create a new penrose triangle, and now let's take a look at the camera object alignment options. By default, the alignment is set to none, but if I set camera to object, then this will align the camera rotation to the illusion alignment of the object. So if my illusion alignment is set to isometric, and I set the alignment to camera to object, then that means that the camera will be rotated from its current rotation into a rotation that matches the optical illusion. Now, if I also set the illusion alignment to axonometric, then I can change the illusion angle, and the camera will automatically follow the new optical illusion. That way, you can decide which proportions and which optical illusion angle do you want before starting to create your scene. Instead of aligning the camera to the object, we can also align the object to the current camera rotation. For example, if I delete my camera and my triangle, let's say I create a new isometric camera, I create a new penrose triangle, I set the proportions, the illusion alignment to be viewed from 65 degrees in the X rotation. I can also rotate the object to match the current camera angle. If I set the alignment to object to camera, you can see that it rotated my object so that the illusion can view from the current camera angle. In this mode, I can also play with the proportions of the object by changing the illusion alignment angle. Here you can also change the tilt of the object to rotate it around the camera axis. The last tool that I want to share with you for this video is the camera transform. If you hit camera transform button here, and then you see the transform orientation, you can see that now we have a new one that is called illusion camera. This orientation is aligned to the current camera rotation. This means that if I click on an object and move it on the illusion camera C-axis, it will change its location in the global view, but it won't change its location in the camera view. This tool is particularly useful if you want to animate an object moving around the Penrose triangle. For example, if I create an icosphere and I move it to one of the corners of the triangle, if I move it in the global C-axis, then that would break down the optical illusion. However, if first I move it on the illusion camera C-axis until it is in front of the Penrose triangle, then I can move it down and I still preserve the optical illusion. One thing to keep in mind is that if you rotate your camera, then you also will need to update your camera transform orientation manually, so that it matches the new camera rotation. Now I want to show you how I created this scene using the Paradox Toolkit and the alignment tools. First I create an axonometric camera, and then I create a Penrose triangle. For the Penrose triangle, I will choose the camera object alignment to camera to object, and the illusion alignment to axonometric. Now, if I change the axonometric angles, then the camera will follow the Penrose triangle illusion. So I will set this to 60.5 and 20 degrees. I will also scale down the vertical side of the vertical thickness of the Penrose triangle. To add the rest of the elements to the scene, I use mostly primitive objects, a few modifiers, and I arrange them on top of the optical illusion. For example, here you can see that the house is made mostly of cubes, a cylinder for the window, and that I applied a bevel modifier to give these softer edges. To add the border, I use a cube, a bevel modifier, and the array modifier. The building is also mostly cubes that are placed on top of the optical illusion, and here you can see that I took care of aligning the windows with the border of the optical illusion, and I did this using the snapping tool. However, you can also use the 3D cursor to do so. The back of the building is done in the same way, and you can see that I took care that these segments do not intersect the optical illusion code. You can go to edit mode and select the borders of the penrose of the optical illusion and move them in the vertical direction in order to make sure that they are not intersecting any of the windows or of the slabs of the building. Finally, for the grass, I use a subdivided plane and a particle system that emits these simple grass objects from each vertex of the plane. That way it looks arranged like if it was done using an array modifier. Actually, you can also do it with an array modifier. For this scene, I actually use the viewport render instead of EV or cycles. I do so by first changing the outline to white. Then I set the viewport shading to matcap, and I pick this black matcap line. Then I pick the cavity and I select both types of cavity, world space and screen space, and rise them as much as I can. And this gives this black material with the white outlines. Then in the render panel, under film, make sure that transparent is checked, and then you can go to view and viewport render. be sure to also disable the overlays with this button here. And now actually viewport render. And you can see that you have your object with a transparent background that then you can overlay using another software like GIMP or Photoshop. One disadvantage of the Paradox Toolkit is that you need to decide on the optical illusion angle very early on, so that you can build your scene around it. That's why, when working with optical illusions, I try to make my assets as modular as possible, so I can rearrange them easily if I then decide to change the camera angle or make a variation, without having to redo everything from zero. And that's it for this tutorial. I hope you liked it. If you did, then consider giving it a like and subscribing to the channel so that you can get notified when the next tutorial comes up. You can also follow me on Twitter, where I post my artworks and my work in progress using the Paradox Toolkit add-on.